Assalamualaikum warahmatullahi wabarakatuh and a very good morning. So today we are going to continue with the second method for chapter 5 under the course Chemical Reaction Engineering. So for chapter 5, collection and analysis of rate data, the second method is called integral method. So generally what we have here, we have the rate law. So minus RA is equals to Ka Ca alpha. So this is a general rate law for when we have a reaction of A converted to products. If we write it in differentiation form, we got minus RA is equals to minus dCA over dt equals to KaCa alpha. Then for this second method, what do? We have to integrate the differential form. Okay, in this topic, what we will do is we are going to guess, we are going to check whether the reaction follow zero order, first order, or second order. That would mean we will assign the alpha as 0 for zero order, alpha equals to 1 for first order, and alpha equals to 2 for second order. Okay. So how do we integrate? So for the reaction of A to products, whereby it is carried out in constant volume reactor, generally the rate law is represented by minus RA, rate of disappearance of A, equals to minus dCA over dt equals to KCA alpha. So basically the equation we simplify as minus dCA over dt equals to KCA alpha. Now we move the minus to the right hand side. So we got dCA over dt equals to minus KCA alpha. The first assumption is we assume that the order is 0. So alpha is equals to 0. So we will modify the bold equation. We replace alpha with 0. So the left hand side stay dCA over dt equals to minus K. We have Ca to the power of 0. Anything to the power of 0 is equals to 1. Hence, the equation will just become dCA over dt equals to minus K. Now, how do we proceed? We accumulate all the Ca term on the left and T term on the right. So we have dCA equals to minus K dt. Integrate both sides from Ca to Ca naught, where at t equals to 0, Ca equals to Ca naught, at t equals to t, Ca equals to Ca. Integrate the left-hand side from Ca to Ca naught, 1 dCa, equals to minus k integration from t to 0, 1 dt. Integration of 1 dCA, we will get Ca. So we integrate from Ca to Ca naught, we have Ca minus Ca naught equals to minus K. Integrate t to 0, 1. Integration of 1, we got T only. So T to 0, we got minus KT. We can rearrange or just stay like this. We rearrange, we get Ca. We just move minus Ca naught to the right hand side. So here you can see we have already made a linear equation. Ca is y, Ca naught is c, minus kt is actually mx. Y equals to mx plus c is the linear equation. So what we have to do now to prove that the reaction follows zero order, we have to make a graph of y versus x. Y-axis in this case will be Ca, x-axis will in this case will be time. And if our R square is high, then only we can say that, yeah, it follows zero order and our slope is minus K. So we can find K. We have from here, we can get our rate law. We can rewrite back our rate law. Now, let's say we cannot justify yet whether the R square is high or not. So we compare all order. Okay, let's proceed with first order. Similar like previously, we got dCA over dt equals to minus KCA alpha. So this bolded equation, we will put alpha equals to 1. saying that we are guessing that the order is equals to 1. So we modify the bolded equation. We got dCA over dt equals to minus kCA. So CA to the power of 1 is CA lah. Then we put all CA on the left hand side, dt to the right. So we rearrange to get 1 over CA dCA equals to minus k dt. Integrating both sides, CA to CA naught, 1 over CA dCA equals to minus k integrating t to 0 dt. So integrating the right hand side will always be similar, minus k. Integrating of 1 dt, we will get t. So the right hand side will be similar lah. However, integrating 1 over CA, we got ln CA over CA naught, because from CA to CA naught, so CA, CA naught. Now we have ln CA over CA naught equals to minus KT. We can proceed like this, or we can remove the minus. So we transfer minus from the right to the left. When we transfer, then CA naught and CA will switch position. We have ln CA naught over CA equals to KT. You can see from this graph. Hence, to prove whether the reaction follow first order or not, we need to plot a graph where our y here, our y-axis will be ln CA naught over CA. Ln CA naught over CA, our x-axis will be time. If the R square is high, then yeah, we can say that the reaction follow first order reaction and our slope will become K. Hence, we can rewrite the red law. Okay. Finally, we have second order. So we have dCA over dt equals to minus kCA alpha. Alpha is equals to 2. So we have dCA over dt equals to minus kCA square. Rearrange to put CA on the left hand side, T on the right hand side. We have 1 over CA square dCA equals to minus k dt. Again, the left hand side will be the same. Integration from T to 0, 1 dt will get T. So that will be minus KT lah. While the left hand side integrating from CA to CA naught, 1 over CA square dCA will be minus 1 over CA minus negative 1 over CA naught equals to minus KT. Then we can simplify the equation by multiplying both sides with negative. We get 1 over CA minus 1 over CA naught equals to KT. So we can rearrange or simply use this equation. Rearranging is also fine to get y equals to mx plus c. So in this case, our intercept will be 1 over CA naught lah. So to prove that it is second order, we have to plot a graph where the y-axis will be 1 over CA and our x-axis is time. So if the R square is high, then our slope will be K. Right. So but the idea is, remember, whenever we plot a graph where, for example, we assume that the alpha is equal to 2, the order is equal to 2. If we plot 1 over CA versus time, and we did not get a linear curve, a linear line, instead we get a curve, hence it means that it did not follow that order. In this case, it didn't follow the second order lah. Okay. All right. So let's recap back. So integral method is very simple. What do? We have to write the red law in differential form, and then we have to integrate. Then we evaluate whether it's zero order, first order, second order. We will modify the equation based on the order. So if zero order, we have to plot a graph of CA versus T. If we've got a straight line, then it's true, it follows zeroth order. Our slope will be minus K. If it's first order, we have to plot ln CA naught over CA versus time. If the R square is high, then the slope will be K. If we assume it is second order, we have to plot a graph of 1 over CA versus time. If it's true, then the slope will be K. Let's say we don't know actually which order it is. The best way is for us to plot all the three graphs and see which one has the highest R square. Okay. All right. Below is the equation representing their order. Okay, let's see an example. So here we have a table, and then they ask us to determine the order of reaction and specific reaction rate, that will be K, from batch data for reaction A converted to B. So we have A converted to B. And then we have a series of time and concentration of A by time lah. Well, we know the rate law is generally equals to minus RA equals to minus dCA over dt equals to KACA alpha, since there's only one reactant. Okay, so what do? We have to evaluate all the three. Okay, first one, we have to evaluate whether it's 0th order. Then we have to plot CA versus T to fulfill the equation of CA equals to CA naught minus KT. We evaluate also if alpha is equals to 1, then we have to plot ln CA naught over CA versus T to fulfill this equation. If let's say we want to also evaluate the second order, alpha equals to 2, we have to plot 1 over CA versus time. So we need the same x-axis, time. So time, we do have the data. Then for the y-axis, we need CA for alpha equals to 0. So it was given from the table just now. So we have CA already, so we can plot the graph representing 0th order. For first order, we have to find ln CA naught over CA. Then we have to calculate lah. CA naught, we know it's actually CA at time 0. So our CA naught is 4 in this case. So we can calculate ln CA naught over CA. For second order, the y-axis will be 1 over CA. Then we just divide 1 divided by 4 for time goes to 0 and so on. Okay. So we complete the table for us to plot all the three graphs. So we have our new data. We have 3 sets of data. The x-axis is going to be the same. The y-axis is going to be different depending on the order. So we plot the graph. Okay, let's see. This is the graph for alpha equals to 0. We plot CA versus time, and we get R square equals to 0.9103. This one I plot using Excel. Then we try for alpha equals to 1. We plot ln CA naught over CA versus time. Things to take note is, if you notice, there is no C. C is equals to 0. Hence, when you draw it manually, for example, or even if you draw it using Excel, you have to ensure that the trend line will touch 0. Okay, it's different from this part. This part, you do have the intercept. The intercept is actually CA naught for alpha equals to 0. But alpha equals to 1, your intercept must be 0. Okay, ensure that the trend line will touch the 0, 0. Okay, so here we have R square, 0.9898. Okay, finally, for alpha equals to 2, we plot 1 over CA versus time. This time, we do have the intercept, where the intercept is actually equals to 1 over CA naught, positive 1 over CA naught. We simply remove, transfer this minus 1 CA naught to the right-hand side. So here we have R square equals to 0.7487. Now we compare the three. We can see that alpha equals to 0, 0.91. Alpha equals to 1, 0.98. Alpha equals to 2, 0.74. The correct one would be alpha equals to 1. So the reaction is actually first order. Okay, since we have finalized that the reaction follow first order, then we can find our K. K in this case will be our slope. You can see from here, y equals to mx plus c, where c is equals to 0. So our slope is our K. So alpha equals to 1, K equals to the slope, which is equals to 0.1807. Then we can write the rate law. Rate law is minus RA equals to KCA alpha. We can put the value. We have minus RA equals to 0.1807 CA. So now we have already finalized our rate law. So that's all for today. Let's continue in the next video for the exercise. Thank you very much, everyone.